Hey guys, today we continue our study of exponential functions. And so today we're going to look specifically at equations. And you're going to actually see how you've actually dealt with this last year when you did compound interest. Look at my equation that I have right here that shows exponential growth. It looks a lot like this that was on your formula chart last year, where it said A equals P, which was the principal. 1 plus R, which was always a percent that you had to change to a decimal. And then T was time, usually in years. So doesn't that look a lot the same? Because it is. So you have done this before. So we're going to learn how to look at an equation and kind of dissect it and tell what all the parts mean. And then we're going to look at a word problem and create an equation. And in both situations, we'll solve it. So it says the number, for example, 1. Oh, well, first, let me just point out real quick. This right here is the starting point. And that is probably the most important thing. I think just try to get that straight in your head. It's also your y-intercept. And we'll talk about that a little bit more later. So the original parent function looks like this. Y equals A times B to the power of X. And so A, remember, is the y-intercept, and B is the constant rate of change. And so you can kind of compare it to what we have now, where B is being represented in this format. So again, let me read this example 1. The number of users in millions that belong to a social networking site can be represented by y equals 1.5 times 1.4 to the power of t, where t represents the number of years after 2013. Interpret the parameters of this equation. So if you look at A equals 1.5, which is 1.5 million users at the start. The start being 2013. If I graphed this, if I put this equation in Desmos, it would do this. It would look like this. But really and truly, you're only looking at the y-intercept on. You're actually only looking at this, because this is the starting point right there. So again, just remember that Desmos is going to have it go on and on and on forever. But we have situations where I can't have negative people. Okay, what does B represent in this situation? The 1.4 shows growth because, well, I'm going to tell you that that's your B, because B is greater than 1. So I can just look at it. I can just look at the equation, see 1.4, and know that it's growth. If it was less than 1, it would be decay. What is the R? The R is our rate of change. And since the R is represented by 1.4, if I subtract 1 from it, I get the 0.4. 0.4 as a percent is 40%. So it's 40% growth per year. Again, I can know this just looking at the equation. So if it continues at this rate, the question is, how many users will they have in 2025? Well, if I take 2025, subtract 2013, then we're talking about what will be the growth after 12 years. So I take my equation, 1.5 times 1.40 to the power of 12. I put this in my calculator, and I get around close to 85 million users. Let's look at another one. The prize for a radio station. This time we're going to actually create one. begins with a $100 gift card. Once a day that a name is announced, the person has 15 minutes to call, or the prize will increase by 2.5%. Write an equation to represent the amount of the gift card in dollars after T days. Okay, so what do we have? Our A, our starting point is 100. Our B is going to be, let's see, we have to take our 2.5% and change it to a decimal, 1, 2, which is 0.025. So our B is going to be 1 plus 0.025, which is 1.025. So I'm going to go ahead and create my equation. Y equals my starting point, which is A, which is the 100. My rate of change, which is my growth, 1.025. And that is to the power of T. And then the question asks after 10 days. So now I'm going to take this same equation and I'm going to put it to the power of 10. And I come out to, what do I come out to here? Y equals, well, I'll put it down here. Y equals $128. I don't know how I got my decimal off. Let me erase that. $128.01. So again, on a graph, it really would just start up like this. It would start right here at 100, and then it would go up. Okay, let's look at decay. Decay is when B is less than 1. So we have another situation here, and it says a fully inflated child raft is being used as a pool. The raft is losing. There's your subtraction right there. 6.6%. Move the decimal over twice, I get 0.066. The raft contained 4,500. There's my A right there. There's my starting point, my y-intercept. So I have y equals 4,500. Whoops. 1, because it's losing, I know to subtract 0.066, which ends up being y equals 4,500. Oops, I almost forgot my t. And this number here ends up being 0.934. Now I can just look at this equation and see that it's going to be decay because B is less than 1. So now I'm going to put 4,500.934 to the power of 7, and I will get y approximately, that's where these little wiggly marks come in, 2790.23, and we're talking about cubic inches, so I'm going to put it to the power of 3. Now the next example we're going to skip. We're going to end right here. If you have any questions on the assignment, just let me know. Bye-bye.